All right, let's dive into another deep dive. Today, Firebase and Angular, specifically how to make them work together. You want to know how to use Firebase to build a really solid and secure Angular application, right?
Right. Yeah.
So we'll walk through every step from setting everything up at the beginning to creating those super important security rules, Firestore rules that keep your data safe. Might uncover some interesting facts along the way, maybe even a couple of aha moments, you know?
Yeah, definitely. Firebase is an amazing set of tools for building, well, web and mobile apps, of course.
Right.
And Firestore it's flexible NoSQL database. Security is super important, right, when you're dealing with user data.
Yeah.
And Firestore rules, they give you that fine-grained control, like who can access what data.
Yeah. Okay. So let's jump right in. Like the first things first, what do we need to even think about before we start integrating Firebase into an Angular project?
Well, think of it like building a house, right? You need a solid foundation before you start adding anything else. So in this case, that foundation, it's Node.js, NPM, the Angular CLI, and of course you got to have a Firebase account.
Okay, right, of course. Those are kind of the basic building blocks.
Yeah, exactly.
For any Angular project. So then what?
Okay, so once you have those in place, head over to the Firebase console, and you'll either create a brand new project or select one you've already got. Then once that project's set up, you'll find some really important configuration details, like in the project settings. Think of these details as your VIP pass, your access to Firebase.
Oh, okay.
Treat them with care, keep them safe.
Gotcha, keep them locked down.
Okay, so then how do we actually connect our Angular project to this Firebase project we just set up?
All right, so we use NPM. It stands for Node Package Manager, and we use it to install the libraries we need. That's Firebase, the main one, and then AngularFire.
Think of them like bridges connecting your Angular project to everything that Firebase can do.
So Firebase itself gives us the core functionality, and then AngularFire, that kind of translates it all so it works nicely within our Angular project.
Exactly. And the great thing about Firebase is it's really modular.
Okay.
You only install what you actually need.
Okay.
Kind of like adding tools to a toolkit, right? You know, authentication, you just install at AngularFire Uth. If you're using Firestore, you grab in at AngularFire Firestore. You just add what you need, keeps your project nice and streamlined.
Right, so you're not adding a bunch of unnecessary stuff to your project. Okay, so those configuration details that we got from the Firebase console, where do those actually go in our project?
Okay, so we're going to store those securely in your environment files within your Angular project.
Okay.
These files, they usually live in a folder called environments, and they have names like, you know, environment.ts for when you're developing, and then environment.prod.ts when you're actually in production. This separation makes sure that we're not accidentally, you know, exposing sensitive information in a live environment.
Ah, so it's like having separate blueprints,
Right?
you know, for the prototype and the final product.
Yeah.
Okay. So once we have those safely tucked away in those files, what's next?
All right. Now we need to introduce Firebase to our Angular app. This happens in the app module. It's kind of the heart of your Angular project. It lives in a file called app.module.ts. We'll import the Firebase modules and providers here, essentially telling our app, hey, we're going to be using these Firebase services.
Okay, so it's like registering Firebase with the Angular application, giving it access to all that cool stuff we're going to use.
Exactly.
But with great power comes great responsibility, right?
Yeah.
How do we make sure that all our data in Firestore is like really secure, protected from people who shouldn't have access to it?
That's where Firestore rules come in. They're like gatekeepers, right? They stand guard at your database and carefully check every single request, like whether it's to read data or write data. They're really powerful. Let us define exactly who can do what with that precious data.
Okay, so I'm starting to see how important these rules are. So what does a basic Firestore rule look like? How are they structured?
They're actually written in a very clear and logical language.
Okay.
Start with a rules version declaration, which just specifies the version of the rules language you're using. Then you declare servicecloud.firestore. That just means, hey, these rules, they're for Firestore. And the core of the rule is in the match block. That's where you define what specific documents these rules should protect.
Okay, so the match block, that's where we get really specific. Like we're tailoring the security rules to particular documents or collections.
Yeah, exactly.
Yeah.
Within that match block, you define patterns using wildcards. They target different parts of your database. It's very flexible, lets you apply rules to entire collections, specific documents, or even individual fields within those documents.
Okay, wow, that's pretty powerful.
Yeah.
So if I have a collection, let's say called user data, I could create rules that only apply to the documents in that specific collection.
Exactly.
But what kinds of things, or I guess actions, can we control with these rules? Like what kind of access can we actually restrict?
You have a lot of control. You can control 4 fundamental actions. That's read, write, get, and list. And these correspond to, reading data, writing data, fetching specific documents, and browsing the contents of a collection.
So we can say who can see what, who can modify the data, even who can browse through the collections in our database.
Exactly. You can even break down read into get and list.
Okay.
And write into create, update, and delete, giving you incredible control.
Oh, wow. So we've got those matching patterns. We've got the actions we can control. But how do we actually link these rules to specific users or actions? Like how does authentication come into the picture?
Right. So Firestore rules, they work really well with Firebase Authentication, letting you define rules based on the user that's logged in. We can use this variable, request.auth, inside our rules to check if a user's authenticated. We can even access their UID, their unique identifier.
So we could say like, hey, only authenticated users can see this data, or only the user who created this document can change it.
Exactly. And it's a really powerful way to make sure that sensitive information is protected. We can even go a step further, and say only allow actions if the user's email has been verified. Adds an extra layer of security.
Right. Wow, this is getting really impressive. We're not just building an app, we're creating this secure environment for all the data. But how do we make sure that the data itself, like the actual information, meets certain criteria before it's even allowed into the database? Can we control that with these rules as well?
Absolutely. Data validation's key, right? You want to make sure your data's good. Firestore rules, they can handle that.
Okay.
You can define rules that actually check the structure and even the content of the data that's being written, making sure it follows your specific requirements.
So it's like having a bouncer at the door, making sure only the right kind of information gets in?
Yeah, a perfect analogy. You can specify required fields, enforce data types, and even use pattern matching to make sure the data is formatted correctly. Everything's got to be tip-top before it's stored in Firestore.
Right, right. Okay, so we've covered matching patterns, basic operations, authentication, data validation. This is pretty powerful stuff. But what if our validation logic gets really complicated? Like, how do we keep the rules manageable, make them easier to understand?
All right, so when things get really complex, custom functions are your best friend. They let you break down complicated validation logic into smaller, reusable chunks, kind of like having a toolbox full of specialized validation tools.
Okay, so it's like creating helper functions
Yeah, exactly.
for specific validation tasks.
Exactly.
And we use those within the match blocks. Okay, cool. So far we've covered a lot. Matching patterns, controlling who can access what, authentication, making sure the data is good, and even custom functions. It's a lot. But before we wrap up this deep dive into rules, what about accessing other documents within those rules? Like, can our rules look at information from other parts of the database?
You're thinking like a true security architect. And yes, absolutely. Your rules can do more than just check the document involved in the current request.
Right.
They can actually grab data from other documents using the get function.
Okay.
Opens up all sorts of possibilities. You can create really sophisticated and well-connected security policies.
Wait, so our rules can do detective work, gathering information from different parts of the database, and then make decisions based on that?
Yeah, exactly. Let's say you have a posts collection where users can, submit content, right? But you only want users that are marked as authors in a separate users collection to be able to post.
Okay.
Using the get function, your rules can check the user's role in that users collection before allowing them to write to the posts collection.
Oh, wow. That's really smart. So we're basically cross-referencing information from different parts of the database.
Right.
To make sure everything aligns with our security policies.
Exactly. This ability to access other documents, it gives you so much flexibility and power with Firestore rules.
Yeah. Okay, this is really cool. It's like the rules are making intelligent decisions.
Yeah.
Okay, so we've talked about matching patterns, operations, authentication, data validation, custom functions, even accessing other documents. I'm starting to feel like a Firestore security expert.
Great.
But before we actually start putting these rules into practice, are there any best practices, any guidelines we should keep in mind when we're writing these rules?
Absolutely. There are definitely some best practices for crafting effective rules and secure rule, the kind that'll keep your data safe.
Right.
One of the most important principles is the principle of least privilege.
Okay, principle of least privilege. Sounds important. What does that even mean, like when it comes to Firestore rules?
It means you start with a default denial approach, and then you only grant specific permissions as needed.
Okay.
It's kind of like guilty until proven innocent for security. Right, right.
It minimizes the risk of accidentally exposing data that should be protected.
So we're basically saying, like,
Hmm.
no one gets in unless we explicitly say they can.
Exactly. That's a
Okay.
great way to build that secure foundation.
Okay, okay. What other best practices should we be thinking about?
Layering your rules, that's another important technique. Instead
Yeah.
of having, one massive rule, you break it down into smaller, more manageable conditions. Kind of like building a wall with like multiple layers of bricks.
Right.
Makes it easier to understand, to test, and to maintain over time.
Right. So we want the rules to be like clear, concise, and easy to understand.
Exactly.
What about performance? Like, should we be thinking about how our rules might impact how fast our app runs?
Always a good idea to think about performance, especially when you're dealing with lots of data or really complex rules.
Mhm.
Minimize the number of get operations in your rules because those involve fetching data from the database, which can, slow things down a bit.
Whenever you can, use the exist function to check if a document exists without actually retrieving its data. And always try to keep your rules simple and clear to avoid any potential timeout issues.
Got it. So keep it clean, efficient, and easy to understand. Any other crucial security tips before we wrap up this whole section on Firestore rules?
Always, always, always validate user input.
Okay.
Never just blindly trust data that's coming from the client side. Your rules, they should be like your final line of defense, making sure that even if some bad data tries to sneak in, it's caught and rejected before it can do any harm. Oh, and to make things even more secure, think about using server timestamps. For any time-based operations, it prevents any manipulation by clients.
Okay, so it's like a double check system just to make sure everything's verified and secure before it gets into our database.
Yeah, exactly. Robust security is all about having layers of protection and thinking about everything carefully.
This has been a great deep dive into Firestore security rules. We've talked about a lot, like matching patterns, controlling data access, authentication, validating data, even creating those custom functions, accessing other documents, and all those best practices. I'm definitely feeling a lot more confident now about, keeping my data secure. But before we move on, how do we actually test these rules to make sure they're working the way we want them to?
Great question. And testing is absolutely essential, right? You got to make sure your rules are watertight. Lucky for us, Firebase has this awesome tool. It's called the Firestore Security Rules Emulator.
Firestore Security Rules Emulator. Sounds kind of futuristic. What is it exactly?
Think of it like a virtual testing ground for your rules. You can simulate your Firestore database and test your rules against it without actually affecting your live data. You can even write unit tests to check specific scenarios, make sure your rules behave exactly how you want them to.
So it's like having a security testing lab, but on our own computer.
Yeah.
That's really cool. So how do we start using this emulator thing?
Okay, so first you got to install the Firebase CLI. That's your command line interface for working with Firebase. Once you've got that installed, you create a separate file just for your rules tests. Usually you'd call it something like firestore.rules.test.ts. In that file, you'll write tests using a testing framework like Jest, Mocha, or Jasmine.
So we create this separate file where we define all these different scenarios and we check if the rules are doing what we expect.
Yeah, exactly.
So what do these tests actually look like?
You can basically pretend to be different users with different roles, different data inputs to different actions, and then you check if your rules allow or deny those actions. For example, you could test if a login user can read their own profile, or if a user with a certain role can write to a collection, or if someone who's not logged in is blocked from seeing sensitive data.
So it's like we're role-playing different user interactions, right?
Yeah.
And seeing if our rules catch any unauthorized actions.
Exactly. It's really important for making sure your database is well protected. Now, to actually run these tests, we use that Firebase CLI again. You start the emulators with the command firebase emulators.start. This creates that local environment where you can run your tests. Then you deploy your Firestore rules to this local environment using Firebase deploy only Firestore.rules.
Okay, so we deploy our rules to this simulated environment, and then we unleash our tests on it.
Exactly. And the emulator, it'll give you detailed feedback, like whether each test passed or failed, helping you pinpoint any weak spots in your rules and make those necessary adjustments.
That's incredibly useful. It's like a safety net, right?
Yeah.
Helps us catch those security holes before they become a problem in our real application.
Exactly. Thorough testing is absolutely critical when you're building secure applications.
Okay, this has been an amazing deep dive into Firestore security rules. We've covered so much, from matching patterns to controlling data access, integrating authentication, validating data, creating custom functions, accessing other documents, and following all those best practices. I'm feeling much more confident about my ability to build a secure system for all my data now.
Yeah.
But before we move on, are there any final bits of wisdom, anything we should really keep in mind as we go and build these secure apps with Firestore?
Just remember, security is an ongoing thing.
Okay.
It's not just a one-time setup. As your app changes, it evolves, make sure you review and update your rules. Make sure they match your data model, your access requirements. Aim for clarity and simplicity in your rules to make them easy to understand and easy to maintain over time. And probably most importantly, don't be afraid to test. The Firestore Security Rules emulator is your best friend.
Excellent advice. Okay, so we've laid a solid foundation with dependencies, environment files, and we've gone deep into Firestore security rules.
Okay.
Now let's see how all this actually translates into using Firebase services within our Angular application. What's next on our Firebase adventure?
Let's talk about some common data access patterns, the ones you might run into when you're creating those Firestore rules.
Okay.
These patterns, they kind of give you a blueprint for handling those, typical security situations, make your life a bit easier as a developer.
Okay, so these patterns are like pre-made security templates that we can just adjust to fit what we need.
Exactly.
Okay, that's super helpful.
Yeah.
So what's the first pattern that we should know about?
One of the most common ones, and probably the easiest to understand, is called public read, authenticated write.
Okay.
Pretty self-explanatory, right?
Yeah.
Anyone can read the data from those documents or collections,
Okay.
but only people who are logged in, authenticated, can actually write or change the data.
Okay, that makes sense, yeah. It's kind of like a public bulletin board, right?
Yeah.
Anyone can see what's posted,
Exactly.
but only certain people can add new stuff or change what's already there.
Yeah, exactly.
Where would we see this pattern being used, in the real world?
Well, imagine a blog, right? Anyone can read the articles,
Right.
but only registered users can post comments or write new blog posts, or maybe a product catalog where anyone can browse the products, but only, the store administrators can update the inventory or the prices.
Right, okay.
It's a good pattern, finds a nice balance between being open and keeping things secure.
So how would we actually set this up? This public read authenticated write pattern, using those Firestore rules, would it be really complicated to do?
Not at all. It's actually pretty simple. Inside the match block, for those specific documents or collections, you would just say, allow read if true.
Yep.
That lets anyone read the data. But then for write access, you enforce that authentication by saying allow write if request.auth null.
Oh, okay. So we're making this clear separation between those read and write permissions based on whether someone's logged in or not.
Exactly. Keeps things nice and clean.
Yeah. Elegant and efficient.
Yeah.
What other patterns should we know about, for our security toolkit?
Another common one is called role-based access control.
Okay.
You assign different roles to users, and those roles, they determine what they're allowed to do in the app. It's about managing access based on, a user's responsibilities or their privileges within the system.
Okay, so it's not just about whether they're logged in or not.
Right.
They actually have specific roles.
Exactly.
Give them different levels of access.
Right.
Okay, I can see how that would be really useful for applications that have, different types of users with different permissions.
Yeah.
Do you have a real world example of where we might see this?
Sure. Think about a project management app.
Okay.
You might have administrators, project managers, team members, and then clients,
Right.
administrators. They might have full control over everything.
Okay.
Project managers, they can create and manage projects. Team members, they can contribute to, specific projects.
Right.
And then clients, they can only see the details that are relevant to them.
Right. Okay, so each role has a specific set of things they're allowed to do. basically.
Exactly.
And we can control that with the Firestore rules.
Yes, you would typically store those user roles in a separate collection, maybe called roles,
Mm-hmm.
and then you can use that get function we talked about
Okay.
inside your Firestore rules to retrieve the user's role,
Mm.
and then you can determine their permissions based on that.
So it's like our rules are actually checking what their role is
Exactly.
before deciding whether to allow them to do something or not.
Right.
That's pretty powerful.
It is, yeah.
But what if we need to be even more specific?
Yeah.
Like, what if we want to control access, not just at the document level, but like for individual fields within a document?
You're thinking ahead. That's great. That's called field level security.
Right.
It basically lets you control access to specific fields within a document based on the user or their role.
Okay.
It's like having this super fine-grained security filter, that makes sure that only the right people can see or change that sensitive information.
Right. Okay. So we're not just protecting the whole document.
Right.
We're protecting like little pieces of information within that document.
Exactly.
Okay. Yeah, I can see how that would be super important for apps that deal with like really personal user data.
Absolutely.
Can you give me an example? Like where would we use this pattern?
Sure. Think about like a social media app. Users have profiles.
Mhm.
They have public information. They have private information, right?
Right.
You might want everyone to be able to see their name and their profile picture, but only their friends can see their email address or phone number.
Okay.
That's exactly what field level security gives you.
Right. So we can choose to show like certain parts of the information depending on who's looking at it and who that data belongs to.
Right.
That's pretty cool. How do we actually set that up, like using the Firestore rules?
Within your rules, you can check the values of specific fields, or you can use that request.auth.uid variable to compare the viewer's ID to the document owner's ID.
Okay.
That lets you create rules like, if the visibility field of this document is public, then anyone can read it. Otherwise, only let users whose ID matches the owner id field read it.
So we're basically building like conditional statements, right?
Sure.
Based on certain values in the fields or attributes of the user.
Right.
It's like adding like a layer of intelligence to those security policies.
Yeah, that's a good way to put it.
Okay, cool.
Yeah.
So we've learned about those 3 data access patterns: public read, authenticated write, role-based access control, and field-level security. Is there anything else we should keep in mind when we're designing those Firestore rules?
Just always remember, security is a mindset, right? Always be on the lookout. Think about those potential weak spots.
Okay.
Don't just trust data from the client side, and always double-check user input.
Right.
Review and update your rules as your app changes.
Mm-hmm.
And don't forget to test. Use that Firestore Security Rules emulator. It's really helpful.
Great advice. All right, so we've built that strong foundation with the dependencies, the environment files, and now we have this deep understanding of those Firestore security rules.
Yeah.
Now it's time to like put all this into action, right? I'm ready to start using these Firebase services in our Angular app.
Mm-hmm.
What's the first service we should look at?
All right, let's start with authentication. It's a core part of pretty much every app.
Okay.
Firebase has a really powerful and flexible authentication system.
Okay.
It works seamlessly with your Angular project, makes managing user logins, registrations, all that stuff super easy.
Okay, so this is how we control who can access our app, right? It's like having a bouncer at the door, checking IDs, making sure only the right people get in.
Exactly. And Firebase Authentication, it takes care of all the hard work for you, provides those secure methods for authenticating users using different providers like email and password, Google, Facebook, and more.
Right. Okay.
And the best part is AngularFire, the library we installed earlier, that gives you those convenient services that make it so easy to integrate Firebase Authentication into your project.
Right. Okay. So AngularFire is like our helper, making all this authentication stuff much easier.
Exactly.
Sounds a lot better than trying to write all that code from scratch.
Yeah, for sure.
So can we walk through an example? Like how would we set up a simple email and password authentication system using Firebase and AngularFire?
Sure. You would start by creating an authentication service in your Angular project. Let's just call it auth service for now.
Okay.
This service, it's going to be like our command center for everything authentication related.
Okay, so auth service will be the expert on handling all the logins, registrations, and logouts.
Precisely. And within this service, you'll inject the auth service from AngularFire. That gives you access to all of Firebase Authentication's powerful methods.
Gotcha. So we have our auth service, we've injected the auth service, and we're ready to start using Firebase Authentication.
Right.
What do we do next?
Now, we define those methods within auth service, to handle the main actions: login, register, and logout.
Okay.
These methods will have all the logic for each action, keeps the code neat and organized.
Okay, so we're creating functions, basically,
Yeah.
that represent those actions.
Right.
It's like building our own little authentication system right in our Angular project.
Exactly. Gives you a ton of flexibility to customize the user experience and integrate authentication really smoothly into how your app works.
Right, that's cool.
So for the login function, you'll create a method called login. It'll take the user's email and password. Inside this method, you use the sign in with email and password method from the auth service.
Okay.
That attempts to authenticate the user with Firebase.
So that's the actual Firebase method
Right.
that checks the user's info against our Firebase project.
Exactly. And it returns a promise
Okay.
that either, resolves if it works or rejects if there's a problem.
Okay.
Promises, they're really important for handling those asynchronous operations. Make sure our app doesn't freeze up while it's waiting for authentication to finish.
So promises are how we deal with these checks happening in the background without stopping everything else.
Exactly.
That's pretty neat.
Yeah, it's a handy way to handle things.
So what about registration? How do we do that?
Similar to the login, you'll create a method called register. It also takes the user's email and password.
Mm-hmm.
Inside this method, we use create user with email and password from the auth service to create that new user account in Firebase.
So we're basically doing the same things we could do in the Firebase console.
Yeah.
But we're doing it with code right in our Angular app.
Exactly. Gives you more control and flexibility.
Okay, cool.
All right, so we've got login and registration covered. What about logging out? How do we handle that nicely?
Yeah.
For logout, we create a method called logout. It simply calls the sign out method from the auth service.
Okay.
This ends the user's Firebase session, effectively logging them out.
Got it.
Nice and easy.
So our auth service now has all the methods for managing those user accounts: login, register, and logout.
Right.
But how do we actually use this service in our Angular components? Like, how do we connect all this authentication logic to what the user sees and interacts with?
That's where Angular's dependency injection system comes in.
Okay.
We can inject our auth service into any component that needs to deal with authentication, makes those methods available right there in the component.
Okay, so if I have a component that shows a login form,
Right.
I would inject auth service into that component,
Exactly.
and then I can use its methods to handle the login attempts.
Precisely. You'd call the login method from your auth service within your component's logic,
Right.
passing in the email and password from that login form.
Okay.
And remember, login returns a promise.
Right.
So you use .then and .catch to handle successful logins and any potential errors.
Right. Promises, they let us deal with those different outcomes in a nice way, give feedback to the user, and tell them what to do next.
Exactly.
What about when a login is successful?
Mhm.
Like, how do we know that's happened, and how do we redirect them to the right part of the app?
Within that block of your promise, you can access the user's authentication data, like their UID and other info.
Okay.
You can use this to, figure out their role, permissions, anything else you need to make their experience better.
So we're not just logging them in, we're using that information to, personalize their experience in the app.
Exactly. It's powerful stuff.
Yeah, that's cool. What about when a login fails? Like, what if they get the password wrong or there's an error? How do we deal with that?
That's where that .catch block comes in. You can catch any errors that happen during the login and show the user a message.
Okay.
Like invalid email or password or something went wrong, please try again.
Right, so it's all about handling those errors gracefully.
Exactly.
So that the user knows what's happening and what to do.
Right.
Okay, so we've talked about authentication in detail, from setting up that auth service to handling logins, logouts, and errors.
Mm-hmm.
It's pretty amazing how easy Firebase makes it to do something as complex as authentication.
Yeah, it's really well designed.
It feels almost effortless.
That's the beauty of Firebase. It just makes, common challenges like this much simpler, lets developers focus on the fun stuff, building those great user experiences.
Okay, I'm ready for more Firebase magic. What other cool services should we explore?
All right, let's talk about Firestore. It's Firebase's NoSQL document database. Super flexible, super scalable. It's a whole different way of storing and managing your app data. Much more intuitive than those traditional relational databases.
Firestore.
Yeah.
Yeah, I've heard great things about it, especially for dealing with those really complex data structures. What makes it so different from the relational databases that I'm used to.
Well, think of Firestore like a well-organized filing cabinet, right? You store information in documents, and then you group those documents into collections. These documents, they can hold all kinds of data, text, numbers, lists, even nested objects. Gives you a lot of freedom in how you structure your data.
So instead of those rigid tables and rows, we have these like flexible documents that can like adapt to what we need.
Exactly.
Okay, yeah, I can see how that would be super helpful, especially for apps where the data structure might change over time.
Right.
But how do we actually like work with Firestore in our Angular app? Is it hard to integrate?
AngularFire to the rescue again. It provides a bunch of services that make interacting with Firestore a breeze. You'll mainly use the Firestore service. It gives you those handy methods for adding data, retrieving it, updating it, deleting it.
Okay, so Firestore is our go-to for everything related to Firestore. It's like our
Exactly.
direct connection to the database.
Right, and just like we did with authentication, you usually create a separate service in your Angular project to keep things organized. Let's call it data service.
Okay, so data service is going to be our Firestore expert handling all the details of talking to the database.
Right.
What kind of methods would we like put in this service to manage our data?
Let's start with adding data to Firestore, right? You'd create a method, maybe call it add item. It takes the data you want to store as an argument. And inside this method, you would use the add doc function from the Firestore service. You tell it which collection to add the document to and give it the data.
So AdDoc is like our delivery service, taking our data and putting it in the right spot in Firestore.
Exactly. And it returns a promise, just like with authentication. It resolves with a reference to that new document you created so you can track it and manage it in your app.
Okay, promises, they're everywhere in Firebase. It seems like they're the way to handle all those, those behind-the-scenes operations.
Yeah, they're key for asynchronous stuff.
What about getting data back out of Firestore? How do we, like, fetch that information we stored?
That's where the getDocs function from the Firestore service comes in. It's really versatile. You can use it to fetch all the documents in a collection, or you can be more specific and query for certain documents based on certain conditions.
Oh, so we can either grab everything or we can be picky and only get the documents we actually need.
Yeah, exactly. And getDocs, it gives you a snapshot of all those matching documents, and you can easily go through them and grab the info you need.
Okay, so we've got adding and retrieving data covered. What about updating or deleting documents that are already in Firestore? How do we do that?
To update a document, you use the updateDoc function, give it the document reference, and tell it which fields you want to change. For deleting, you use the deleteDoc function, just pass in that document reference. Firestore makes data management surprisingly easy.
So we've got the whole set, create, read, update, delete, all handled by Firestore and AngularFire. That's awesome.
Exactly, it's all there for you.
Okay, this is really cool. We're building up a really powerful system for handling both user authentication and data storage using Firebase. You mentioned querying data in Firestore earlier. Can you explain how that works in more detail?
Yeah, querying is super important with any database, right? And Firestore gives you a lot of power and flexibility with queries. You can search for documents based on specific field values, ranges, or even combinations of different conditions.
So we can be really specific about what we want to grab from the database, make sure we're only getting the information that's relevant right now.
Exactly. That's really important for building efficient applications, especially when you have lots of data. Imagine trying to find a specific product in an online store with millions of items. Good queries make all the difference.
Okay, let's see some examples. How would we query for all the documents where a certain field has a specific value? Let's say we have a collection called products, and we want to find all the products where the category is electronics.
We'd use the where function from the Firestore service. We combine it with query and getDocs. It would look something like this. Const queue query collection for categories electronics. Const query snapshot equates getDocs queue.
So we're basically defining a query that says, find all documents and products where category is electronics, and then getDocs actually goes and fetches those documents.
Exactly. And Firestore's query syntax is pretty easy to read and understand.
Okay, that's good. What about querying for documents within a certain range? Like, let's say we want to find all products with a price between, I don't know, $50 and $100.
Firestore has comparison operators like less than, or equal to, greater than, or equal to. You can use those with the where function. So to define that price range, your query would look like this. Const queue query collection.firestore products where Price, 50, where
So we're
price.
setting like a lower limit and an upper limit for the price, kind of like when you filter search results on a shopping website.
Yeah, a perfect analogy. And this ability to query based on ranges is super useful for filtering data based on numbers like prices, dates, or ratings.
Cool. So we can query for specific values and ranges. Any other querying tricks we should know about?
You can actually combine multiple where clauses using those logical operators like AND and OR to make even more complex queries. For example, to find products that are either in the electronics category or have a price over $100, you'd use this query: cons Q category, cons Q collection, where electronics are 100.
Oh, wow. So we can build like conditional statements into our queries, combine different criteria to really narrow down the results.
Precisely, it's incredibly powerful.
Okay, we've talked about adding data, getting it back out, updating, deleting, and even querying data in Firestore. I'm feeling pretty good about this. Any final tips for working with Firestore before we move on?
Just remember, performance is always important when you're working with databases, especially when you have lots of data. Use indexes for your queries to speed things up, think about pagination if you have a lot of results, and take advantage of Firestore's built-in caching. Those will all help keep your app running smoothly.
Great tips. Performance is definitely key, especially if we want to give our users a really great experience. Okay, Firestore's checked off the list. What other exciting Firebase services are out there?
All right, let's talk about Firebase storage. It's a really secure and powerful service for storing and serving, user-generated content like images, videos, audio files. Think of it like having your own content delivery network built right into Firebase.
Firebase storage. Yeah, that sounds perfect for apps that use a lot of multimedia content like profile pictures, product images, or even user-uploaded videos.
Exactly. And Firebase storage works really well with the other Firebase services like Firestore, Authentication, and Cloud Functions, making it super easy to build those feature-rich apps that users love.
Okay, I'm definitely interested. How do we start using Firebase storage in our Angular app? Is it as straightforward as authentication in Firestore?
Absolutely. AngularFire provides a handy storage service, your interface to Firebase storage. It handles all your uploading, downloading, and file management in the cloud.
Okay, so storage is our guide to managing files in Firebase.
Right.
What's the typical process for uploading files to Firebase storage?
You'd usually create a service in your Angular project specifically for Firebase storage. Let's call it storage service. Inside the service, you'd create a method maybe called upload file. It takes a file object, which represents the file you want to upload. That file object usually comes from a file input element in your HTML.
Okay, so we get the file from the user, and we pass it to our upload file method. Then what?
Inside upload file, you use the upload bytes function that's provided by the storage service. You give it a storage reference, which is just the path and file name for the uploaded file in Firebase storage, and you also give it the file object itself. It's like giving Firebase storage clear instructions on where to put the file and what to name it.
So we're saying, hey, Firebase storage, here's the file, put it in this folder and call it this. Sounds pretty simple.
It is. And upload bytes gives you a snapshot of the upload process so you can track how it's going and get a download URL for the file once it's done.
Ah, the download URL. That's what we need to like access and display the file later.
Exactly. You use the get download URL function from the storage service to get that download URL for the uploaded file.
Okay, so uploading and getting the URL are covered.
Yeah.
What about downloading files from Firebase storage? Is that a separate process?
Nope. You can use that same get download URL function to get the URL for any file in Firebase storage. Just give it the storage reference for the file you want, and it'll return a promise that resolves with that download URL.
So whether we're uploading or downloading, that download URL is our key to accessing the files in Firebase storage.
Exactly. Once you have the URL, you can use it in your Angular app to display images, play videos, download documents, whatever you need to do with that stored file.
This is also, we've added another super useful tool to our Firebase toolkit. Any final tips for working with Firebase storage?
Always think about security. Make sure you configure those storage rules, control who can upload, download, and change files in your storage buckets. You can use those rules to set limits on file sizes, restrict file types, or add any other security measures that make sense for your app.
Right, we don't want just anyone throwing anything into our storage buckets.
Exactly. Firebase gives you the tools, but it's up to us to use them safely and responsibly.
Well, that brings our deep dive into Firebase and Angular to a close. We've covered a lot today, from the basic setup to authentication, Firestore, storage, and even some troubleshooting tips.
It's been a great journey. Firebase is such a powerful set of tools. It really opens up a lot of possibilities for building amazing applications.
Absolutely. Don't be afraid to experiment, try new things, and keep learning. Until next time, happy coding, everyone.